Wildfires are relentless. In the hills of Los Angeles, flames rip through neighborhoods, leaving only ash and heartbreak in their wake. Yet, in some cases, a single home remains standing amidst the destruction, untouched by the inferno. How does that happen? It's not luck, it's engineering. Could smarter designs have saved more homes? Could it even have saved entire neighborhoods? In this video, we're diving into how engineering could change the future game for wildfire-prone areas like Los Angeles. Los Angeles is no stranger to wildfires. The Woolsey Fire in 2018 burned almost 100,000 acres, destroyed over 1,600 structures, and forced hundreds of thousands to flee their homes. Then, in January 2025, the Palisades Fire spread through steep, brush-covered hillsides, fueled by super strong winds and dry vegetation. Homes of Hollywood celebrities and the wealthy neighborhoods of Malibu and Pacific Palisades were all under fire, literally. Within the first few days of the fire, the total estimated cost was up to $150 billion and climbing. Experts said it was going to be the most costly natural disaster in U.S. history. Fires like these don't just destroy, they disrupt entire communities, leaving scars that can take decades to heal. Wildfires spread quickly for a few main reasons. Lack of rain creates dry vegetation, which acts like kindling, while strong winds carry embers for miles. These tiny embers, called firebrands, are what ignites homes, not just the direct flames. Once a home catches fire, it can set off a chain reaction, spreading the fire to nearby structures. When engineers design homes for wildfire-prone areas, they think beyond just the flames. It's about understanding how fire behaves. Embers are the biggest threat to homes during wildfires. They can sneak into attics, land on roofs, or collect in corners where flammable materials ignite. A lot of times, it is the stuff inside the homes that are more prone to catching fire, not the outside. And surprisingly, the windows are often the way embers get in. The flames around the house get so hot that they actually melt the window frames, causing the windows to completely blow up, creating an easy passage right into the house. So, the trick would be to prevent the embers from getting into the house in the first place. Believe it or not, engineers have already designed fire-resistant homes that can combat this. These innovations are called passive houses. And during the Palisades Fire, one passive house stood standing, and it drew attention from media all over. Now, what makes these modern engineering marvels so resilient? Well, most importantly, passive houses have features that make them super fire-resistant. They are also designed to be super energy efficient and sustainable. So, what sets them apart? Let's break it down. Airtight construction. At the center of a passive house's design is its airtight construction. Every crack, seam, and connection in the house is sealed tight, leaving no room for embers to sneak inside. Engineers call this the airtight envelope, and it serves two purposes: keeping the house safe from embers and maintaining a consistent indoor temperature. Fire-resistant materials. The materials used in passive houses are carefully chosen to resist fire. Roofs are often made of metal or clay tiles that won't ignite, while the walls are constructed from materials like stucco, fiber cement, or concrete. These materials can withstand extreme heat, acting as a barrier between the fire and the structure. And inside the walls, the insulation is usually made of mineral wool or fiberglass. Unlike traditional insulation, these materials don't burn easily, adding another layer of protection. Triple-pane windows. Like we talked about earlier, windows are a weak spot in most homes during a wildfire, but not in a passive house. These homes use triple-pane windows, which means there are 3 layers of glass with airtight seals in between. They're not just heat-resistant, they also improve energy efficiency. Many of these windows also have something called a low-E coating, which reflects heat and protects the interior from intense temperatures. Smart roof and eaves design. Passive houses avoid designs that create vulnerabilities, like open eaves or attic vents. These features are prime spots for embers to collect. Instead, the roofs are sealed with ventless designs and smooth soffits that leave no space for firebrands to gather. But what if your house wasn't originally built to be a passive house? Well, you don't need to start over from scratch to benefit from these features. Many fire-resistant designs can be added to existing homes, which is called a retrofit design. For example, people could swap out a wooden roof for a metal one, which would be a game changer. Fire-resistant caulking around windows and doors would help seal the home's envelope, preventing embers from entering. Upgrading to double or triple pane windows with tempered glass would also add tons of protection. And let's not forget making sure your house has a defensible space. Clear any flammable vegetation around the house and replace it with gravel or fire-resistant plants. This would create a buffer that could stop a fire in its tracks. While this all sounds fine and dandy, it seems there are always downsides to every great design. And as impressive as passive houses are, they're not perfect. The biggest challenge is cost. Fire-resistant materials like triple pane windows and metal roofs are expensive, making them a tough sell for homeowners on a budget. And because passive houses are so airtight, they require advanced ventilation systems to maintain the air quality inside. These systems work well, but need regular maintenance to stay effective. There's also the issue of accessibility. Retrofitting an older home with all the features of a passive house isn't always feasible. Some houses simply weren't built to support the weight or structural changes required. Despite these drawbacks, the benefits often outweigh the costs. Not only do these designs reduce the risk of wildfire damage, but they also improve energy efficiency, saving homeowners money in the long run. But while protecting individual homes is a start, entire communities need to adapt fire-resistant strategies in order to truly tackle the wildfire problem. Local governments, engineers, and urban planners play a critical role here. By updating zoning laws to require fire-resistant construction in high-risk areas, they can make sure new developments are better prepared for wildfires. And community-wide efforts to maintain fire breaks, which are areas cleared of vegetation that slow or stop wildfires, and defensible spaces can greatly reduce the spread of fires. Also, there are smart sensors being developed to detect nearby fires and alert homeowners in real time. Companies like Frontline Wildfire Defense are creating remote-controlled sprinkler systems that can soak a property with water or fire retardant at a push of a button. AI is also stepping up. Advanced fire mapping technology uses artificial intelligence to predict how a fire will spread, allowing firefighters to use their resources more effectively. This kind of data-driven approach is already saving lives and homes. So, could smarter engineering have saved Los Angeles from some of the devastation in 2025? The answer is a resounding yes. If there were more passive houses and fire-resistant retrofits, more homes could have been saved. And community planning and fire breaks could have saved entire neighborhoods, while technology could save lives. Wildfires are becoming more frequent and more intense, but we don't have to accept them as inevitable disasters. With the right combination of design, technology, and planning, we can build a future where homes and lives are better protected from the flames. Thanks for watching. We hope you enjoyed learning about how engineering can play a role in saving entire communities from wildfires like the Palisades fire in the future. Do you think LA will be able to rebuild itself into a fire-resistant city? Let us know in the comments below. Be sure to check out our other videos and remember to like and subscribe to our channel because engineering is for everyone.